Well, hello everybody, and welcome to today's webinar. We're going to be talking about getting started with Virtual Reactor 21.1. The webinar will be presented by Sam Clark, and I'll introduce him in a moment. My name is Peter Blazer, and I will serve as your host today. This webinar is being recorded, and so if you missed something or want to share something you saw with a colleague or a friend, you'll be able to do that. The recording will be posted up at cpfd-software.com/resources/webinar. But I don't expect you to remember that. But if you go to our website, click on the resources tab, and in the menu, you'll see webinars and presentations, and those are all posted up at our website. So that will be posted probably in the next 24 hours. We would like this webinar to be interactive, and so we need your help. Please, as you're watching the materials, as you think of questions, put those into the questions panel. We have intentionally allocated a significant amount of time to address your questions after the presentation, and you can help by making that interactive. If you have a question, as you're thinking of it, please put it in right away, and that'll help us stay organized during the Q&A session at the end. For those of you who are maybe new to CPFD software, let me briefly introduce our company. Here at CPFD Software, we are advancing multi-phase simulation and technology for fluid particle systems, and those are primarily fluidized bed reactors. Our Barracuda Virtual Reactor software product models the 3D transient hydrodynamics, the heat balance, and chemical reactions in industrial units. And it's typically used to improve the reliability and performance of these systems through simulation. These are often industrial units that operate 24/7 for quite possibly years on end. And so for operating units looking inside, determining the root cause of phenomena under performance, being able to reduce the risk of making any changes through virtual testing, and invariably, as you're looking at the software results, other ideas come to mind. Additional optimization opportunities are identified. And for those of you developing new technology, Barracuda Virtual Reactor is used to accelerate, to broaden that R&D, and then quickly commercialize and scale up and communicate the merits of your technology to customers, to partners, and others. So that's who we are. Let's get right into the webinar itself. Speaking to you today will be Sam Clark. Sam has been with CPFD for nearly 14 years now, doing a little bit of everything, customer support and training and testing and helping with the development team, many years running engineering service projects. And today, Sam is the Barracuda Virtual Reactor product manager, and so you're in good hands with Sam. So Sam, over to you.
Great, thanks, Peter. And thanks to everyone who's watching the webinar today. The development team here at CPFD was hard at work in the fall of 2021 on this release, so I'm happy to be doing this release webinar and let everyone know what the new features are and how you can most effectively use them. If you are a Barracuda user, you should have received a release email in December of 2021, and so if you didn't receive that, please let us know, and we'll make sure that you're on our email list for future release announcements. Version 21.1 is available for download now on CPFD's support site. So if you haven't gotten it yet, I encourage you to log into the support site and download it and get it installed. The outline for today's webinar is the same or follows the structure as the release guide in the user manual. So if there's anything I talk about and you want to see more information about it, go to the release guide and it'll give you some more details and also links to the full chapters within the user manual for each feature. One thing that we've continued to work on is improving the GPU acceleration performance in Barracuda. And every user who runs Barracuda in GPU parallel mode will benefit from this, both on Windows and Linux. The plot on this slide shows timing results for a simulation with about 240,000 real cells and almost 30 million clouds. And this was run on one of our DGX-1 systems that has 8 NVIDIA V100 cards. The orange bars show simulation speed for version 21, and the blue bars are for this newer release, 21.1. For single GPU simulations, our tests are showing that this release is about 10% faster than version 21 on average. If you're running Barracuda in multi-GPU mode, which is supported on Linux only, you'll see better performance also. We've improved the scaling significantly for many problems, which means that you'll see greater benefit when running on 3 or 4 GPUs for a single simulation than you would have seen in previous releases. We also ran tests on a number of other simulations with different sizes, so that you can see how the solver scales as you run more clouds, more cells, things like that. The figure on this page shows timing results that we ran on an NVIDIA DGX station with A100 GPU cards, and these are the current latest and greatest GPU cards from NVIDIA. The trends we're seeing here are consistent with what we've been seeing in the past releases, like version 21, except the speeds are a little bit faster across the board. One thing we're still seeing is that large simulations tend to benefit the most from multi-GPU acceleration. Based on our tests, simulations with about 10 million or more clouds gain significant speed up when you use 2 GPUs. And if you have a simulation that has like 40 million clouds or higher on this A100 system at least, then you can get substantial gains by adding a 3rd or 4th GPU card to that simulation. The second conclusion that we're seeing is that 2 GPUs is typically giving the greatest incremental benefit. For the 3 largest cases shown on this plot, using 2 GPUs is about 70% faster than using a single GPU. If you add a 3rd GPU, you get an additional performance gain of about 20%. And if you add a 4th GPU, you get a performance gain of about 10% more. We are always working on our GPU code, trying to improve the scaling. And so we anticipate that future releases should scale even better as well. But this is some progress that we're seeing from 21 to 21.1. So a lot of times customers email us and they say, well, should we buy new GPU cards? Here's a plot that compares the performance of the previous generation cards, which were the V100s, with the current generation cards, which are the A100s. One thing to keep in mind about this sort of plot and the plot on the previous page is that the NVIDIA A100 cards are so fast and they have so much memory that they really open up new possibilities in terms of how large a simulation can be. And they also, you have to run a very large simulation in order to fully take advantage of their capabilities. So as we see here, for this particular problem with 240,000 cells and about 30 million clouds, it takes about 3 V100s working together to equal the simulation speed of a single A100. You do see that with the V100s, as you keep adding more cards, you get significant benefit all the way up to 4 GPUs, whereas with the A100s, this problem is not quite large enough really to keep the scaling going as you add the 4th GPU especially. One thing I want to be clear about is that the big picture message I'm trying to communicate here is not a negative statement about the V100 cards. They're definitely great cards and they give impressively high simulation speeds. Instead, I just want to make sure that people are aware of what the different generations can do in terms of simulation speed and give you some good guidance when you're looking to purchase new hardware or thinking about cloud computing costs or licensing costs. You know, there's always these trade-offs of the newer generation hardware could very well be more expensive than the older generation and so forth. So just to help people make good decisions. It is sometimes tough to buy GPU cards still, and this is kind of similar to what we were seeing last year. It can be hard to find the newest and fastest cards, because demand is quite high, and we've seen some cards being sold at premium prices above MSRP. So one thing to consider if you want to take advantage of the fastest speeds available, but you don't want to buy hardware, you can't find hardware to buy, is you can run Barracuda on the cloud. And so you could run on cloud providers such as Azure or AWS or Google Cloud. We have worked with a number of Barracuda users to run on the cloud, and so far we haven't had any issues getting access to instances that have A100 cards. So that hasn't been an issue so far in our experience. If you're interested in learning more about that, feel free to contact our support team, and we'd be happy to talk to you about it. One thing that we've had a few questions come up over, say, the past 6 months or since the release of 21.0 is people asking, how can you really run multiple GPU simulations? So we want to make sure that everyone knows a few things that are kind of like license related in terms of multi-GPU. So the first requirement, as I mentioned earlier, multi-GPU is only supported on Linux systems, so keep that in mind. You do need to have access to a Linux system to do this. If you already have multiple GPU licenses and you have 2 or more GPU cards, you have the ability to run multi-GPU today. Each GPU card that you use for a simulation in multi-GPU mode needs to be able to check out a GPU license. And so you can use as many GPU cards as you have GPU license tokens on a single machine, right? This doesn't span across multiple machines in terms of that GPU parallel capability. If you need to add more GPU license tokens to your RLM server, please contact our sales team. It's possible and it's easy to add GPU tokens mid-term, and we can definitely work with you to make sure that the licenses you have are meeting your needs as efficiently as possible. If you have any questions about hardware, please contact our support team. We'll be happy to help you select the best GPU cards for your budget and your situation. We partner with a number of companies such as NVIDIA and Mark III Systems, who are in the business of getting people the right hardware, and they have distributors all over the world, so we can definitely connect you with the right people there. In case you missed our joint webinar about the DGX A100 system, I would encourage you to look at our website in the resources section that Peter mentioned and find that webinar there, because that DGX Station A100 system is a pretty amazing system. That's the fastest one we've tested on so far. One more thing to keep in mind also is that RLM cloud licenses can make it very easy to run either on-premise with your own hardware or in the cloud, or a combination of the two. So if you're not familiar with RLM cloud licenses, please let us know. We can definitely answer questions about that. It's a very convenient way and a lot of times easier than managing your own on-premise RLM server. Okay, let's take a look at a few of the new physics capabilities in version 21.1. One thing is that in this release, baffles have been updated so that they can act as heat transfer surfaces, and very similar to the way that thermal wall BCs have been able to perform in the past. We're hoping that the introduction of thermal baffles really helps you to make your simulations more realistic and gives you some flexibility where sometimes it was difficult to define a thermal wall BC in just the right place. In order to specify thermal properties, you'll notice that the Baffles setup GUI has been updated, and there is now a properties column. And so if you click the edit button in that column, it will launch a new dialog. And one thing you'll notice is in this dialog, we've moved the K factor fields into here so that the main Baffles table is all location related information. And then this dialog contains more like physics related information. So the K factor X, Y, and Z fields These are the same as they were in the past, but they're just relocated into this dialog. To use the new thermal capabilities, you would check the box that says thermal baffle, and then this would tell the solver that it needs to apply your specified temperature, and you can do either a constant temperature or a time varying temperature through an SFF file. And then if you have a radiation model enabled, then these fields for emissivity and scatter factor would also be applied to the calculations for radiation. Another new feature that we're really excited about and interested to see reaction from customers is the ability to have dynamic fluid distribution at injection BCs. And so what this does is it, for each injection BC location in the system, it looks at the pressure in the cell where that injection BC is located, and it allocates either more or less fluid flow based on that local pressure. So this feature is intended to allow more realistic simulations of gas distributors that have a large number of holes. When you're defining a fluid injection, you can enable this new feature by clicking the checkbox that says dynamic fluid distribution, and then you can specify what is called an orifice discharge coefficient. And this is something that you can find in reference books, or your design team might know this value already. And so you plug that in there. And I'll show in a moment, the user manual also shows what the equation is that actually uses this term. To show what this does, I think it's useful to show a demo. So here I'm going to drop out of presentation mode for a second and show just an example that we've set up here to illustrate what happens when you enable this feature. So here I'm showing the setup of one case of our demo, just so you can get an idea of what this is. Just a simple cylinder with a simplified distributor. So in many cases, your distributor could very well look more complex than this. But basically, we have one distributor pipe with a series of injection BCs along each side, and then a pressure BC at the top. And then we have a bed of particles around the distributor. And within our Barracuda project, here's the right half of the injection BCs, the left half of the injection BCs, and an orifice discharge coefficient that we've defined for this particular case. What we've done here to illustrate this is set up 3 different cases so that you can see kind of what the effect of this is likely to be. The leftmost case here is what I would call our base case. This is actually without the dynamic fluid distribution feature enabled. So if you were to use injection BCs in previous versions of Barracuda, this is what you would have seen, right? The fluid flow is always applied kind of at a constant flow rate through each injection BC, and there was no variation based on the local pressure. The middle case is representative of a well-designed distributor that has a good pressure drop across all the holes with the dynamic fluid distribution feature enabled. So this is kind of what I would expect a lot of your simulations to look like. Most people have fairly well-designed distributors with good pressure drop, and so a lot of times you're not going to see, highly non-uniform flow. So if you enable this feature, a lot of times this is kind of the difference that I would expect is, very, very uniform without the feature, a little bit more non-uniformity with it enabled. If you have a really poorly designed distributor, or a distributor that has very low pressure drop across the injection nozzles, then you could see something more like this third case. So in this case, we did a case with like quite low velocity with low pressure drop across the injection BCs, and we saw some really big variations in the fluid flow distribution with this feature enabled. So kind of just a spectrum of what you might be seeing in different situations. And probably most people are going to be kind of in this middle situation, where if you have a well-designed distributor, you're not going to see a whole lot of difference, or not too extreme, non-uniformity. Okay, I think that's what I wanted to say about that. Oh yeah, I did want to show the user manual equation too, here. So just to be aware of this, if you're wondering how to set the orifice discharge coefficient, the pressure drop that the solver is internally calculating is directly proportional to the velocity at each location, and it's inversely proportional to this orifice discharge coefficient. And you can look this up in reference books. There is a reference provided here. Based on our research, it seems like 0.8 is usually a reasonable value. So when you enable this feature in the GUI, 0.8 is the default value, but you can certainly change that if there's a more appropriate value for your distributor. Okay, let's jump back into the PowerPoint and continue on. Okay, so based on customer requests, we added a few new variables to the user-defined expression parsers for both drag models and chemical reaction rate coefficients. We want to make sure that everyone's aware of these in case they are useful for your setups. In the drag model parser, we added the variables x, y, and z, and these correspond to the x, y, and z positions of the particle in units of meters. So be aware of that. You can do some drag model modifications based on those particle location variables. Within the chemistry coefficient editor, we've added a couple of different things. One is gas species concentrations. And so previously you could only reference gas species in your actual reaction rate expression editor field, but now we've added the ability to access these directly within the rate coefficient editor. And so if you want to reference the mole fraction of a gas, you would do NF underscore and then the gas name. And then if you want mass fraction, you can use MF underscore gas name. And then also we added a variable called turbulent viscosity to the coefficient editor. And we're thinking that this should be useful for people who are modeling chemistry that should have some sort of turbulent mixing limitation that could affect the reaction rates. Another place that you'll notice a difference in the GUI is in the raw data window. In the past, this was just a list of checkboxes, and you got like all particle data if you click to the particle checkbox. So we've changed this so that users can select specifically the data that they want and not have to get all of the data. So if you've used raw data in the past and the files took up a ton of disk space, we hope you'll appreciate this. This will allow you to really reduce the amount of space required and get just the variables that you really care about in your raw data files. And this is for both particles and cell data. Another change that we made was with the GUI's open terminal functionality. And our hope here is that this should allow everyone to run utility scripts and Python scripts much more conveniently when you open a terminal from the GUI. To open a terminal from the GUI, I think most people are probably familiar with it, but it's like this little black TV icon. It's in the toolbar, it's in the post-run window, and it's also in the post-processing menu. So with version 21.1, when you open a terminal from the GUI, what it will try to do is activate the base environment of Anaconda Python. And this is the Python distribution that we generally recommend to people because it can make it really easy to run Jupyter notebooks. It comes with a lot of modules that are very, very useful for post-processing. And so now when you open the terminal, it will activate this for you, and it'll make it much easier to just start post-processing directly in your simulation directory. And one of our big motivations for changing the terminal behavior was really to make it easy to run these utility scripts that we are including with Barracuda. And one new utility script in version 21.1 is batch movie. For anyone who has been using Barracuda for a number of years, you probably remember the old batchmovie.sh script that we used to create movies from GMV. And so this new batch movie script is very similar in usage and intention, but this helps you to make movies from TechPlot using scripts. And so you can do this on a terminal command line, or you can put the commands in a script, and it should make your workflow a lot more efficient if you have a lot of big movies that you need to make, or if you have a really long running simulation that you would like to keep monitoring with these animations. And so kind of like the old batch movie, this one stores a series of images and it creates an animation from those images, and it will only create the new frames that are needed as the simulation runs. And so it does not go back and reprocess everything. It only processes what it needs to in order to give you the movie that you're generating. So here, I'll drop out of presentation mode one more time and give a little demonstration of what this looks like. Okay, so here, for most people, you'll generally start with some view that you are interested in making a movie from. So here, just for an example, let's say we wanted to make a movie that includes a slice. So here, I'll turn on a slice, and we'll just make a view real quick. Instead of IJK, let's go fluid velocity magnitude. The one true color bar that I love is modified rainbow less green. And then you can set some levels. I think I tried this earlier. I think something like 0 to 2.5 meters per second looked pretty good. Okay, so let's say, oh, too many levels. 0.5. Okay, there we go. So let's say you have a view that you like and you want to make a movie out of this. Be aware that the file that you need to give to batch movie is called a frame style file. And so if you're not familiar with this, you can go to the frame menu, you can say save frame style, and it'll show you all the styles that you've saved previously. This was my previous test one, so we'll just use the same name, slice fluid velocity magnitude.sty. You can save your file, and then if you open a terminal from the Barracuda GUI, you can run your batch movie command with that frame style as an input, right? So if you do batch movie space and then your style file name and hit enter, what you'll see is it starts processing each of your solution times. So in this case, I have 500 solution time files, or PLT files. And so what it's going to do is it's going to go through and make an image for each of those. And once it makes all the images, it puts them together into a final animation. So here, I want to make sure that everyone is aware of this, because this is a small change from the way that batch movie, the old batch movie, used to work. But hopefully this will help keep everything organized. So within your simulation directory, the new batch movie script creates a subfolder called animations. So if you go into animations, you'll see any previous animations that you've made and a folder for all of their images. And then in this case, this is the current animation that's being made as the script runs, right? So you'll see it'll create a new image file for every time step, and it keeps them here, right? And so one thing to be aware of is, like, don't delete this folder of image files, because if you do that, it will have to create all of the images again anytime you want to make this animation again. So keep that until you're really done making animations. Here's one that I've made previously, just to demonstrate what it looks like. So this is a whole folder full of 500 JPEGs, and this is the animation that it created from that series of JPEGs. So you can do a lot of things. You can do vectors, particles, slices, stream traces, all of those sorts of things can be saved in the style file, and you can make your movie that way. Okay, so let me jump back into the presentation. And I think those are all the features that I wanted to point out for version 21.1. So Peter, I'll hand it back over to you.
Great, thank you, Sam. And we are going to get to the questions. Those that are putting in questions, please continue to do so. We'll let Sam catch his breath, have a sip of water, and get to those in a minute. While we do so, I just want to briefly, for those of you who are new to CPFD software, let you know a few different ways you can get started working together with us. Software licensing, which is sort of the default mode we're talking about here, is where you use Virtual Reactor in-house. Typically that has been single site licensing, but in recent years we've seen prevalence of sort of global teams that partner together, and so our global enterprise licensing is also available in many countries around the world. So talk to us about licensing options. As Sam said, those licenses can be served both on-premise on your own hardware or cloud served, which opens the door for you to use both your own hardware and cloud computing resources. For those of you that may have just a one-off need or an urgent need prior to building out a team to run the software, we do have a services team where we offer simulation engineering services and broader level engagements. So talk to us about those types of needs. The easiest way to get started to check things out is with our training programs. We do offer new user training classes. One's coming up next week. I'll give you more information on that in a moment. But we regularly have those training classes, and training can be combined with project work and licensing in what we call our Quick Start program. This is really cool. So what Quick Start is exactly what the name implies, intended to get you up and running quickly. We run the first models for you with our services team. Then we hand those over, the models used, we train you in their use and provide the software licensing for you to then build out your own in-house capabilities with a model that's already up and running. And then lastly, we work with people in a variety of custom ways through various R&D partnerships, whether it's fluidization research, researching new models, technology development, and so forth. And the R&D partnerships can be direct with us or involving other of our strategic partners. So talk to us about your needs. A few upcoming events. Next week, January 24th through 28th, we have our next web-based training class. That class is it's getting pretty full. There may be 1 or 2 seats available. So talk to us. We have increased those to run monthly now. So you can find a future date that works for you as well. Let us know about your training needs. A few different webinars coming up from some of our strategic partners in the coming weeks. On February 2nd, TechPlot is hosting a webinar entitled Master the View, Ask an Expert with product manager Scott Fowler. And for those of you running Virtual Reactor 21.1, you have TechPlot for Barracuda post-processing. So all the powerful stuff that Scott's going to talk about is relevant to you. So please feel free to join that webinar and send me your questions in advance. PSRI is hosting a webinar on February 15th. They're continuing through their Meet the Consultants series. I know many Barracuda Virtual Reactor clients are also PSRI member companies, so check that out. They're going to introduce Dr. Jia Chu, who is the new technical director, and talk about her background and areas of expertise that she brings to their consulting team. There's a lot more events. You can see all of them on our events calendar at cpfd-software.com/events calendar. If you don't remember that, go to our website, look at the community tab, and click on events calendar. One sort of longer term thing I want to highlight is we are very excited to have finally our users conference again, our global users conference in June 2022 is scheduled in Chicago immediately following the PSRI Technical Advisory Committee meeting. So we look forward to hopefully seeing many of you face to face once more. With that, I think that's long enough breather for Sam. I see a number of questions that do keep coming in here, so please keep those going. And then Sam, if you're ready, we're going to get started on asking and answering these.
Yeah, definitely. Let's get into it.
Okay. So the first one here, It says you recently benchmarked multi-GPU on an 8 GPU cloud system. And I think that's referring to the post that Microsoft Azure had put up about 2 weeks ago with some pretty cool benchmarks. Is there a benefit to running on 8 GPUs? Is the question.
Okay, yeah. Um, so, as I mentioned on some of the timing plot slides here, you would have to have a really, really large simulation to take advantage of 8 GPUs for a single simulation. I think the biggest simulation we tested was like 50 million clouds, and that had scaling advantages up to 3 or 4 GPUs on the A100 system. So if you had a very, very large simulation, you might be able to get some benefit there with all 8 GPUs. But what we're seeing more frequently is that for people who have these systems with 8 GPUs, or if you're using an Azure instance with 8 GPUs, kind of the real advantage that you have is that you can run multiple simulations at once, and you could do something like 2 or 3 or 4 GPUs dedicated to each simulation. So you can get that benefit of the GPU acceleration in multi-GPU mode, and you can also get the benefit of just running concurrent cases so that you can investigate a wide design space as fast as possible, right? So those kind of big instances on Azure or AWS, they're definitely useful, especially if you have a number of cases that you want to explore as quickly as possible. You can get some really incredible kind of project turnaround times by using those. The other thing I should mention is sometimes you may not know how many GPUs would be optimum or optimal for your case. So definitely try out our test drive feature. So this means like you can run your simulation in test drive mode, and it won't write out any of the results files, but it lets you run with multiple GPU capabilities, and it doesn't require the licenses to be checked out to do that. And so this is a really great timing tool, right? If you don't know how many licenses you need or how many GPUs would be the most efficient, you can get that information by using the test drive mode of the solver.
Thanks, Sam. I think that's really good advice. I've been doing this a long time, and it never ceases to amaze me what I think I know changes so quickly as hardware changes, as the speed changes of software. Invariably, I remember, running 100,000 cells was like unheard of, and a million particles, and now regularly we're seeing people run 50 million particles or more. So how that scales and what's the optimal does change regularly. So being able to test that out and is really good advice. Okay, here's one. Have you seen big differences when running with the dynamic fluid distribution at injection BCs?
Okay, yeah. So most of the time we're not going to see big differences, and we haven't seen big differences. So for a lot of systems, the distributors are well designed, right? Engineers know what they're doing. They make distributors that have good pressure drops, and so you would have high enough velocity and a good orifice discharge coefficient value. And so generally it's going to be kind of like those first two cases I showed where it's going to look similar to the completely uniform option. However, if you do have streaming in your bed, or there are like gas channels that form that would really affect the pressure at a local BC or a local injection location, then yeah, using the dynamic distributors might give you some really useful information about that, and it would pick that up in a way that the completely uniform case would not. So in general, I think most people are going to see very similar behavior, but it could still be a very useful physical model to enable. And I think one thing that I forgot to mention, but is definitely worth mentioning, is it does not have a very high computational cost either. So based on some timing tests that we did, if you run with the dynamic distributor feature turned on, it has a very negligible impact on runtime. And so it's a very safe feature to enable. as long as you are properly defining your velocity and your orifice discharge coefficient, it can kind of only make things more realistic, right, for most simulations.
Thank you. I think that's a really good answer to that. I know there's a lot of good correlations out there. I'm mostly familiar with the PSRI ones on, recommended minimum pressure drop across relative to bed DP, but it's a tricky thing, because if you want to have a uniform as possible flow through the distributor, you increase your pressure drop, which typically involves raising nozzle velocities. But that could affect your attrition of the particles. So there's a sort of a sweet spot there, and I'm excited that our users now have a tool to be able to explore that further. Okay, switching gears. I think you answered this, but I'll ask it anyways. Are pre-configured hardware let me say that again. Are pre-configured hardware options available with Barracuda installed?
Yeah, we do have a number of contacts in the kind of hardware selling industry. So CPFD does not build and sell computers directly to customers. However, we do have partners like Mark III Systems, who I mentioned earlier with regard to that A100 webinar that we did. So we can definitely put people in touch with those partners, and we can work with those partners to have Barracuda pre-installed, ready to run, so that when a system is delivered, it's just ready to go. So yeah, that is an option, and be kind of working with one of our industry partners to make that happen.
In fact, I recently had a call with Mark III, and they actually service many countries around the world. And so let me find that link to the webinar playback. I'll post it here in the chat window in a minute when you're talking, Sam. But it's pretty cool watching that webinar. The performance has been amazing, and they do have a variety of different options with both the DGX station, which basically plugs in under your desk, looks like a regular computer, but it's got 4 A100s in it. Some of our benchmarking on that one showed 400 times faster in parallel over serial for large problems. And that was just stunning. They also have a DGX server, and so talk to them. I'll post that into the chat window here. And again, you can find more information on that on our website. Okay, this one's related to what you showed about the different parser variables. So it says with particle position available in user drag, is it possible to find different drag models in different parts of my system? And as I read the question, Sam, what comes to mind is, perhaps it's a chemical looping combustion, or some of the carbon capture with sorbents processes where you have maybe a riser that flows through a cyclone down into a bubbling bed, several different beds in different transport regimes. Is it possible to use different drag models in different parts of that system?
Yeah, definitely, and I think that was the motivation from some of the users who had been requesting these variables. They said, hey, I have a really great drag model for bubbling bed regime, and I have another really great drag model for a riser situation, but I can't really use those in a single Barracuda simulation. But now you can, right, with the XYZ variables and kind of the flexibility of the parser expressions. You can definitely isolate spatial regions, and you can do that to give more appropriate drag models to specific regimes in different areas of your system.
That's cool.
Yeah.
People have been asking about that for a long time. Hey, I just put it in for everybody in the chat window is a link to the playback of the webinar with NVIDIA and Mark III Systems about the DGX Station A100. This one says, if I didn't request raw data at the start of the simulation, is it possible to add it later?
Yeah, it is actually. So there's a couple different ways that people approach this sometimes. One is that if you have a simulation that's currently running and you just realize, like, oh no, I should have requested raw data, but I forgot, you could stop the simulation, drop an IC file, and then perform a restart from that point, and you can add raw data on restart, right? And so then you would start to get those data files from the restart point going forward. So if there's something really specific that you want to have from raw data, that's a way that you can get it for a simulation that's currently going. Another thing that we've started to see is that with the move to TechPlot and with there's a tool with TechPlot called PyTechPlot where you can kind of connect to a running TechPlot GUI and you can do all kinds of Python data analysis. We found that that has been very powerful, and TechPlot also has a really good equation parser that can be used to analyze data that's already loaded in. So in some cases, you don't necessarily need the raw data if the data that you have is in your TechPlot visualization files. So, there's been a lot of flexibility there, and so hopefully, one of those two options could help a person get the data they need.
Okay, skimming through here, and by the way, running close to the end of the questions that have been put in. If there's any others you're thinking of as we're talking, please put those in. But the next one I see here, Sam, it says multi-GPU only on Linux, but I run Windows. Is it possible to pre-post on Windows but run the solver on Linux?
Okay, yeah. So like pre-post, I assume means like setting up a project and then post-processing it on Windows and then just using Linux for running the solver, presumably in multi-GPU mode, right? Because that's kind of the real advantage there of switching over. And so, yeah, we have customers who do this. Depending on how your systems are configured, it can look a little bit different, but some people run Barracuda through like SSH connections to a Linux machine, or sometimes we set up VNC sessions to access Linux machines that are remote. But yeah, people definitely do that, where they have the Barracuda GUI up on a Windows machine and the TechPlot GUI up on a Windows machine, but they're really using a Linux machine in the background to run the solver, as efficiently and using that multi-GPU capability to get the fastest simulation speed.
And a related one, does Batch Movie work on Windows?
Okay, yeah. Yes, it does. And so this is one of the really nice things, and we've been working on this for several years, kind of starting with the TechPlot transition, and then we've really made an effort to make all of our utility scripts run in Python rather than like Linux shell scripts that they used to be in the olden days. So now, we have a big focus on kind of equal capabilities on Linux and Windows as much as possible, right? And so Batch Movie works exactly the same way on Windows as it does on Linux, and you can make your movies in batch on either operating system.
Thank you, Sam. If I missed your question, we will answer those after. I do see a few here that are specific to individual use cases, and we'll respond privately to the various companies that have asked those sorts of things. But with that, Sam, I think that wraps up our Q&A. I want to thank everybody who joined us here today, or who's watching this later on playback. For more information, you can visit our website, follow us on LinkedIn, where we regularly post updates on what's new, what's coming, or just contact us. So thank you, everybody, for joining us. Thank you, Sam, so much for presenting, and this concludes today's webinar.